Alright, Algebra1B. Today we got a big lesson. So buckle up a little bit. We're going to be covering some important stuff and stuff I want you to be on top of that'll be a big deal moving forward. We're going to talk today about quadratics. But before we do that, I want to make sure we can review a little bit of our Algebra Fundamentals. So our last chapter was on the property of exponents, which is stuff like this. If you have 2x squared y times 3xy to the third, this would become 6 x to the fifth, y to the fourth, because these powers add and these powers add. But notice each of those just represents one term. That means there's no addition or subtraction. If you have something like this, well, each of these have two terms. They have two terms because there's a plus or a minus in between the terms. So 3x is a term, 2 is a term, 5x is a term, -3 is a term. When you're adding or subtracting, not multiplying or dividing, but adding or subtracting, you combine your like terms. So 3x plus 5x becomes 8x, and 2 minus 3 becomes -1. So you add or subtract by combining like terms. You can multiply anything. So if I'm doing like 3x squared plus 5x, those are not like terms. I can't simplify any further. But if I have 3x squared times 5x, I don't need to have like terms when I'm multiplying. This becomes 15x to the third. So when you have something like this, let's say we have 2x minus 1 times x plus 5. This has to be distributed and then simplified. So first I do 2x times x, which is 2x squared. Then I do 2x times 5, which is 10x. Then -1 times x is -x, and -1 times 5 is -5. And I've done the multiplication. Next, I combine my like terms. 10x minus 1x is 9x. So it's 2x squared plus 9x minus 5. Okay? Some Algebra Fundamentals for us to be on top of. Okay, I'm going to pull up Desmos. Desmos is a graphing tool you can find on the internet, or there's apps for it. I'm going to first graph these two functions right here. Now you might know these are linear functions. So y equals x plus 4 is a line with a slope of 1. And y equals x minus 1 is a line with a slope of 1. Let me graph those. So first here on Desmos, I'll type in, I'm going to do f of x equals x plus 1. I think that's what I said I was going to do. No, x plus 4. And the second one will be f of x, or I'll call it g of x. G of x equals x plus 1. This gives me 4 lines, or 2 lines. I'm not a crazy person. 2 lines. Both these lines have a slope of 1, and both these lines have x-intercepts. Notice how the green line has an x-intercept here at -4, and the white line has an x-intercept here at -1. Well, watch what happens if I multiply these two functions. In Desmos, I can just type f of x, g of x. It'll take my f of x function and my g of x functions and multiply them. F of x times g of x gives me this curve. This curve is called a parabola. So parabolas are going to be the next thing we'd be graphing. Notice how the parabola shares the same x-intercepts as the two lines. So a line has one x-intercept. A parabola can potentially have 2. If a parabola is made up of 2 lines, it'll share the 2 intercepts the 2 lines have. So this parabola has an intercept at -4 and an intercept at -1. This line was -4 and this line was -1. So parabolas are going to be what we're going to be graphing here in the future. Now I said that we did f of x times g of x. Let's calculate that. F of x times g of x would be this function, really this expression, times this expression, which becomes x squared minus x plus 4x minus 4. Combine your like terms here. It becomes x squared plus 3x minus 4. So I made up a new function called h of x, and h of x is x squared plus 3x minus 4. This is called a quadratic. It's a quadratic function because its biggest power is 2. To be a quadratic, you have to have a biggest power of 2. Lines have a biggest power of 1. All right, this is like x to the first plus 4. If your biggest power is 1, you have a line. If your biggest power is 2, you have a quadratic. So we're going to be focused on quadratics for the next chunk of time here in our math class. The graph of a quadratic is called a parabola. Okay, so any function, any equation that has a 2 as its biggest power is called a quadratic, and its graph is going to graph in what's called a parabola that looks like this. Parabolas have some pretty important properties that we'll talk about real soon. Okay, so know how lines can take the form y equals mx plus b? This was our slope-intercept form of a line. The slope is m and the y-intercept is b. Well, quadratics take the form y equals ax squared plus bx plus c, where a, b, and c all represent numbers. Typically they're integers, positive or negative whole numbers. So for example, I could have the equation y equals 3x squared plus 5x minus 6. And we would say that the a value is 3, the b value is 5, and the c value is negative 6. A, b, and c just let us identify and discuss things very precisely. So I could have another function. Let's say it's negative x squared plus 8x plus 1. This would have an a value of negative 1, a b value of 8, and a c value of 1. So see if you can identify the a, b, and c values in these three functions I'm going to write. Okay, so take a second and pause and find the a, b, and c values of these three functions, please. For this first one, the a value is 1, the b value is negative 2, and the c value is 3. The fact that the b value is negative, like the fact that any of these can be negative, is a very big deal. Okay, so they can be positive or negative. For h, the a value is 4. The b value is 0, okay? It is not negative 10. The b value is always whatever's attached to the single x term. So here the b value is 2 because our single x term was 2, or negative 2 really. So here there is no b value. We say b equals 0 and c equals negative 10. So for this one, a equals 1, b equals 3, c equals 0. The c term is always the term that doesn't have an x on it. It's also going to be your y-intercept, which we'll learn in a second. Okay, so being able to identify a, b, and c makes talking about parabolas and understanding these quadratics much simpler. Parabolas have a few really important key characteristics. I have one graphed pretty faintly here on the screen. The first thing that you should always remember about a parabola is it is symmetric. That means I could take half of the graph and copy it over a line, and it would copy over to the other half of the graph. So every parabola is symmetric. This distance here matches this distance here. And this distance here matches this distance here. So they're symmetric about this line that goes through the middle. The point in the middle, the very top or bottom point, is called the vertex. Every parabola has a vertex. So the vertex is the highest or lowest point. See, we're going to see that some parabolas face down and some parabolas face up. So the vertex is always here or here. And this little line that I drew to show the symmetry always passes through the vertex. We call it the line of symmetry or the axis of symmetry. But I'm not going to worry about that too much just yet. Every parabola is symmetric and every parabola has a vertex. Additionally, every parabola has a y-intercept. We'll see the y-intercept is actually quite easy to find. Finally, a parabola can have 0, 1, or 2 x-intercepts. X-intercepts is where your graph crosses the x-axis, and those are called roots. Okay, so a parabola can't have 2 roots like this one does. It can also have 0 roots if it points like this above the x-axis, and there are some cases where it can have 1 root. I think we're going to see all those examples coming up ahead. So for now, we're just going to worry about finding the vertex, the y-intercept, and the x-intercepts, and remembering that parabolas are symmetric to make things easier on us. Okay, so when we start, we're going to be graphing parabolas that don't have a b value. So instead of doing something like 2x squared plus 5x minus 6, we'll just do 2x squared minus 6. Now to start, graphing parabolas is going to be pretty straightforward. We're going to plug in 5 numbers for x. The numbers from negative 2 to 2. And we'll just do that every time. We plug in something for x, and we see what we get out for y, and that makes a point. So for example, I'll start with the easiest one, which is 0. If I plug in 0 for x, I'm doing f of 0. Plug in 0 for x. That becomes 2 times 0 squared minus 6, which is 0 minus 6, which is negative 6. This is the point 0, negative 6, which is right here. That is the y-intercept. It's also, for today, going to be the vertex. Because we're not graphing with a b term, the vertex is always going to be somewhere on the y-axis. Then I'm going to plug in the other numbers, like I'll plug in 1. Now be very careful. I'll start explaining this in the next one actually. This becomes 2 minus 6, which is negative 4. So 1 negative 4 is right here. But when I plug in 2, you have to be careful about the order of operations here. I'm doing 2 times 2 squared minus 6. When I'm doing this calculation, I have to do the squaring first. The squaring has to be the thing you do first because exponents come before multiply and divide. So first I'll get 2 squared, which is 4. Then I'll do 2 times 4 is 8, and 8 minus 6 is 2. This is the point 2, 2. So we have to be equally careful with negative numbers. If I plug in negative 1 for x, if I do f of negative 1, I have to do the squaring first. Yikes. I have to do this first. And negative 1 squared is positive 1. This becomes 2 times positive 1 minus 6. The squaring has to come first. 2 times 1 is 2, and 2 minus 6 is negative 4. So this was the point, negative 1, negative 4. We plugged in negative 1 for x, we got out negative 4 for y. We plugged in negative 1 for x, we got out negative 4 for y. Finally, I'll do f of negative 2. I'm kind of running out of space because I'm not writing very, horizontally here. But f of negative 2 becomes 2. 2 times negative 2 squared minus 6. I do the negative 2 squared first to get positive 4. 2 times 4 is 8, and 8 minus 6 is 2. So we plugged in the point negative 2, got out 2 for x. Plugged in negative 2 for x, got out 2 for y. The parabola graphs like this. Now it's going to be hard for you to draw at first because it's curvy down here at the bottom. The bottom is curvy, and then it kind of starts to look straight, but never actually gets straight. It's always curving just a little bit. So we'll get better at graphing these over time. But notice how this parabola has symmetry. This line right here cuts it in half. These 2 points match, and these 2 points match. That should happen with every single one of these parabolas. You should have symmetry as you're graphing it. Now notice how there's roots. We're not totally sure where they are. They're not quite at negative 2 and 2. So I'm just going to put an arrow and draw and say here's a root and here's a root. I'm not totally sure where it is yet, and we'll leave that alone. But notice how I've labeled a root and a y-intercept and a vertex. I was asked to do all those things. Identify the vertex, roots, and y-intercept. Okay, we'll do 2 more examples of this. But it gets a bit, methodical now. I'm going to just keep plugging in the same numbers for x. And then calculating the y-intercepts and the roots and everything else for y. I'll start with 0 because 0 is very easy. If I do f of 0, that's negative 1 times 0 squared minus 1. This negative right here acts like a negative 1. Well, 0 squared is 0. Negative 1 times 0 is 0. 0 minus 1 is negative 1. There we go. This was the point 0, negative 1. F of 1, so maybe, I hope you can notice this. Whatever your c value is, that's your y-intercept. Here the c value is negative 1, the y-intercept was negative 1. Here, the c value is negative 6, the y-intercept was negative 6. So whatever your c term is, that's your y-intercept. Okay, I'm going to plug in 1. F of 1 becomes negative 1 times 1 squared minus 1, which has a whole lot of 1 in it. I do the squaring first, and 1 squared is 1. Negative 1 times 1 is still negative 1, and negative 1 minus 1 is negative 2. This is the point 1, negative 2, like this. I'll plug in 2, and this won't be quite so deja vu-y, where I say the same number over and over. I'm doing negative 1 times 2 squared minus 1. I do the squaring first, so it's negative 1 times 4 minus 1, which gets me negative 5. Now at this point, I should actually be able to just fill in the other half of this graph, right? Because I know there's going to be symmetry. This point can bounce over here, and this point can bounce over here. So I can use the symmetry of the graph to fill in the rest. Then I draw out my curve, and I fill in my table. But I'm going to show you how to deal with these negatives here, all right? I'm doing negative. So what I'm going to do with this one is I'm going to graph f of negative 2. I'm going to plot and calculate f of negative 2. Well, f of negative 2 becomes negative 1 times negative 2 squared minus 1. I do the squaring first, so negative 2 squared is 4. Negative 1 times 4 is negative 4, and negative 4 minus 1 is negative 5, just like we got. You have to do the squaring first, and you have to recognize that a negative number squared becomes positive. If you type this into your calculator will tell you negative 9. So don't use your calculator. We're going to be working with small, simple numbers to start. Don't use your calculator yet. This has a vertex and a y-intercept at 0, negative 1, and it has no roots. Notice how this parabola doesn't cross the x-axis because it has no roots. Okay, last one. This is the very basic, simple one, right? For this value, the a is 1, b is 0, c is 0. All we're doing is y equals x squared. We're just squaring whatever x is to get y. I plug negative 2, negative 1, 0, 1, 2. 0 squared is 0, 1 squared is 1, 2 squared is 4. I could even do 3 squared is 9, and 4 squared is 16. Negative 1 squared is 1, negative 2 squared is 4. This is the basic parent function of your parabola. Graphs like this. It has a vertex and a root and a y-intercept all at the point 0, 0. Okay. Quadratic functions graph as parabolas of the form y equals ax squared plus bx plus c. Parabolas are symmetric, and they have a vertex, a y-intercept, and can have 0, 1, or 2 roots. Plug in the numbers negative 3 to 3, although we were just doing negative 2 to 2. Plug in the numbers negative 2 to 2 to graph. Always plot and label the vertex, y-intercept, and roots if there are any. That's it for today. We'll practice this more for the next couple days. Can't wait.